Where will this video be posted?
Do you see on my screen these last two links?
Yeah.
So it will be, I usually need it until about the end of the weekend to be able to go and get these posted, but it will always be on my YouTube channel because I link that to my website, and it will be on my personal website as well. So that YouTube channel is here. You can subscribe to that. So anytime I would post something, you would get some type of notification.
Okay.
Or you can look on my website. I can actually jump over to my website right now and show you where it will be. So you're seeing my name is Kelsey Huntsberry on there because my domain name hasn't been updated. Kelsey Huntsberry and Kelsey Mnet will both get you here.
Okay.
Got married, so my name changed. So anytime that I actually put a new video in here, you would come to my website. We don't have any PySpark videos yet, so there's no PySpark link here. So, but it'll say Intro to PySpark, and you'll see that drop down menu here. You'll be able to go in, and I'll show the machine learning one as an example. So this was the machine learning class I just did.
Okay.
So if you go down to class 1, if you join that one, you'll see that all the links that were called out by our guest speaker are right here. So downloading Python, downloading Visual Studio Code, all of that. And then we have a YouTube video here, and then slides under it that go over everything that I went over during class. So, and
That's
this
good.
links directly to the YouTube channel. Okay. So I'm going to go back to the slides just very quickly. And all the files that I'll be using today are going to sit right here. So please feel free to go get those. There it was a deck, and I did send out an email on Tuesday that showed you how to set up the environment if you wanted to go and use Databricks for this class. So I recommend that you would go do that. I'm not going to go through it today. But if you go into Intro to PySpark, you'll have resources here, and Databricks setup guide is going to be there. Keep in mind, Databricks does have a small cost associated with it after your free trial is over. So it'll be anywhere, if you keep a small cluster, between like 30 cents, 8 cents to like 30 cents every hour you use it. So now I'm going to go into the content. I mentioned that I had done previous classes, but I wanted to start this over in order to be able to record for everybody and have this available and make it public as well. So if you joined any of the previous ones, the first half of this is going to be mostly new. The second half will be the review. Please feel free to drop off if you don't want to review again. It's still designed for anybody who hasn't been here before to be able to follow along really well. A little bit about me. I'm Kelsey Mnet, and I'm a senior consultant at Avanade. I have a little more than 5 years of experience in statistical analysis and data science. I'm mostly working on machine learning at the Azure cloud in general, and big data analytics, which is what we're covering today. So we're covering and working with PySpark. Just a fun fact about me, I just got married and built and moved into a new house. I moved in August 8th of last year, so pretty exciting. You can see the house behind me, I'm sure. So a little bit more about what we're going to cover. So what is Spark and why would you use it? Spark enables you to do big data processing. So processing with massive data sets at scale quickly. It does this through parallel processing. So taking small chunks of your data and analyzing them simultaneously on different nodes of a cluster. We're going to get into what the different parts of a cluster look like and how that's done momentarily. But the great thing about Spark is that you have multiple language choices to actually run a Spark application, which is some code that you would want to run. And you can run it in R, Python, Scala, Java, and a SQL as well. We are going to be focusing on the Python in this case, so PySpark. I've noticed when applying for jobs in the past that PySpark is called for and desired much more than any of the other languages when it comes to Spark. So, and it's the one I know. So we're going to go with that. I've used R as well, the Sparkly R. So if you're an R user, it looks a lot like dplyr. So just an FYI. PySpark works on something called Spark DataFrames, which are those data frames that are broken up into much smaller pieces and run across a cluster. I can see the chat right now, so if you do have any questions, feel free to put them in there or to unmute and ask any questions as I go as well. Right. So what will we be covering in this class? The first several classes are going to be on these first two items here. So basic data transformations like filters, selecting columns, things like that. And we'll also be working with joins and aggregations as well. So expect the first part to be more of the data munging stuff. We'll then do some of this along the way here and there and get into it later on even more is actually optimizing Spark code. When you in practice start using really big data sets, you have to code in the right way and check certain things to make sure that you have room on your cluster and that you're setting yourself up for success when you're trying to use large data sets. And I believe the class after this one will be going over koalas, which is actually really neat because it allows you to use pandas from Python syntax in Databricks so that you can still do that distributed or parallelized computing with a normal Python syntax. So it's really helpful here and there. Later on, we're going to be covering working with Data Lake, which is the scalable storage that Databricks has for its customers. Modeling and MLlib, so that's the machine learning package within Spark.
So is it Delta Lake or Data Lake? Because you got Delta Lake.
It's Delta Lake. So
okay.
Delta Lake sits on top of other storage. So say you're using Azure Blob Storage, which is what I'm going to show and use today. It sits on top of that blob storage and allows you to both organize your data and to get it in and out a lot quicker and analyze it at scale. So everything, Spark data frames are stored in Parquet files, which are basically a lot of different files. When you save it, you could save it to say 20 files and then it'll come in as 20 files so that you easily can handle moving that data in and out at scale. So, yep, go ahead.
What's the difference between Data Lake and Delta Lake?
Delta Lake is a product that Databricks puts out. So it sits on top of a data lake from another, like either from Azure or AWS. And I just saw a press release on Monday that this Databricks is now available in Google Cloud, which is super cool. So now the big three, Databricks is available across the big three. So this is just a scalable storage that sits on top of an existing data lake that you have. And it works much quicker and you're able to separate it and I use it as like a bronze, silver, gold landing zone for your data. So you can do the ETL in stages. We'll cover that a lot more in the next time, but that will be kind of down the road. It's very easy to use though, which is really helpful. And then we'll be covering MLlib, which is the machine learning library. And MLflow is used for monitoring and deployment of models. So that will be useful to know as well if you're doing any AI work. All right. So what is Databricks? I want to tell you what Databricks is and how is it different than PySpark, and where would you use one versus the other. So Databricks is the platform we will in this class be running PySpark with. You can run PySpark in a lot of different places. You can run it on AWS EMR, Azure HD Insight. You can even actually have a local Spark cluster on your computer, and that would be a great choice if you don't want to pay for this class for the actual Databricks platform to use that. I'm not going to go over how to create a local Spark cluster. I've never done it myself, but if you Google creating a local or Spark cluster, there are a lot of resources on it. So hopefully that will be good. The Databricks Community Edition is also a free version. It doesn't have all the features, but it would be a great thing to use if you don't want to pay that $1 or so to use it every couple of hours. So Databricks, there's a reason why I'm teaching this in Databricks. Especially I've used AWS EMR. The differences that I see is it's extremely easy to use Databricks. There's very little setup except for getting your data in. It gives you default features that are really good. So you're not going to have as much complexity with the setup. It also has extra features like koalas, which I talked about, which parallelizes Python pandas code. So people who already know Python can work really well. Delta Lake, it is open source, and so is MLflow, but they're made by Databricks, so they're well incorporated into the platform. And then there are two other things that I really like. You can change a Spark language from R to SQL to Scala to Python, all within the same notebook with 2 lines of code. So if you're doing something in Python that's really good at Python, but you know that SQL has another option that's a lot simpler than the Python code you're trying to write, you can quickly change to SQL, write it, and change right back. So that's really helpful. The last thing is also extremely important. In AWS EMR, the different languages run at different speeds. So Scala is going to run a lot faster than a PySpark or Sparkly R. So the R and the Python versions, because it's translating to Spark SQL in the backend. So Databricks has optimized their code to run this at almost the same speed across all the different languages. So that's something that's not available in other platforms, that once you get up to really large data sets, that really actually matters quite a bit. So that is why I'm choosing to use that versus another one of these platforms. You can use whatever you want. You will be able to follow along for the vast majority of it. So based on your personal circumstances, do whatever you'd like. Again, those Databricks setup instructions are in here. If you go to the Intro to PySpark folders, which is the bit.ly link, the bit.ly/intro to PySpark with hyphens between the words. And this will go through in painful detail on how to do everything and to how to get your data into Azure so you can use it in Databricks. I found that when I taught that in the last class, nobody could really follow along anyway, so it was better to kind of do it out of the class. So now actually getting into the Spark architecture. So I recently took the Databricks developer or Spark developer exam and went through and studied a lot, and I felt like the architectural information and the way they laid it out was really helpful for understanding how the code was running and what you should do. So the first part, the next like 20 minutes, we're going to go over Spark architecture so you can understand at a high level what's going on behind the code. And then we're going to jump in and start doing some coding demos. So the first thing, we talked a little bit about this, it's data partitioning. So in order to run things at scale, I already told you that Databricks or PySpark, it takes and puts your data into smaller chunks. and distributes them throughout a cluster. We're going to talk about clusters more in a second. But for now, think about the data partitioning. Each a subset of rows in your data set are going to sit on these different nodes of the different clusters. And that allows for parallel processing or running that data simultaneously across those nodes. You can scale from anywhere from 1 to thousands of nodes in a cluster. And I've done anywhere from 1 to 800 nodes, and I've used that, and you would change it based on the size of your data. So when you think of data partitioning, your mind is probably going up to this first graphic up here. But so you're thinking everything's kind of split apart and put equally on different nodes or executors in your cluster. We're going to cover the difference between a node and an executor in a second. So that is, and I in reality, not exactly what happens. And I want to put that up front. So, in reality, the data tends to be split unevenly across your different nodes, because as you do joins and filters, Spark tries not to move anything across the different nodes unless it has to. So as you're doing filters and joins, it's going to end up being uneven the data across your cluster. If you start to see decreased performance, and we're going to talk about this later, this is something that you'll want to keep in mind, that you want to make it and put it back to this ideal area. That's down the road, but I want you to be able to kind of picture what this looks like. Are there any questions, and to stop before I move on to the other areas?
I'm good.
Any questions? Bueller?
I'm good.
All right. Okay. Feel free to put anything in the chat if you want. So here's the meat of it. I keep saying nodes and executors, and I'm using all these terms. This is what it actually means. So you have a driver program in Spark, and you can think of that as something that takes your code, which you would call a user application. You can see it here. And it breaks that application up into smaller tasks to execute across those nodes. And it schedules those tasks on different parts of your cluster. So it communicates with the other areas of the architecture. It communicates with the cluster manager and as well as the worker nodes. But the cluster manager actually manages and allocates the resources to your different worker nodes. And on a worker node, you have both an executor, and then you actually perform tasks on that executor. So where worker node is what is actually doing the work in Spark. So it's taking those, if you filter your data, it's actually filtering its section of its data, and it's returning that data, which is communicated by it's communicated back to the driver. And that everything is done on executors within those worker nodes. So they execute the actual tasks assigned by this driver node up here. So it sends the instructions down to the executors saying do X, Y, Z. And then that is done and the information is sent back. Those executors then communicate that back to the driver. And for the executors, all the data on its particular partition in that executor is kept in memory or on disk. So it is working with that small section of the data held in memory or on disk. And then a task you can think of as any job assigned by the Spark driver that can be done on one single node or executor. So it is being done by like one section of the computer, you can think of as this, because you're using multiple virtual machines in this case. So that one node task is a unit of work that it does, and then it does multiple tasks. And then at the end of the day, you have jobs that are performed by Spark that have tasks, multiple tasks associated with them. I'm going to show you in real time what this looks like, and we'll get a little bit more into the details. And when you see it, it'll become a little more clear exactly what I'm talking about. All right. So this is extremely important. Tasks, actions versus transformations. You need to know the difference between the two, especially for debugging purposes, because if you don't know this is happening, I found that people I've helped with Spark coding get tripped up by this a lot because they don't understand what's happening on the back end. So a transformation is when you change a Spark, when you do something in a Spark data frame, that can be done without, it does something called lazy execution. I'll put it like that. So if you're using something called a select or a filter, basically those things, it can select columns and it can do that on all the different nodes of the cluster without having any information about the other parts of the cluster. It can do a filter with that without knowing what's going on in the other parts of the cluster. So when it's able to do some of these tasks, they're evaluated lazily, which means unless you're calling and triggering an action, which is the action that we'll talk about in a second, whether you're printing something or counting something or returning a value, it's going to hold off on running those functions until you actually perform an action. So it adds a step to the plan. And at the end, it finds the optimal way to actually perform that plan by reordering, by changing and splitting up the tasks differently across the cluster. I'll talk about more like what that looks like in a second, but it adds that step to a plan. The action is when you actually trigger it to perform that line or list of actions or transformations over here. So the filters, the joins, everything. So say I print or should ask to show me the top 20 rows of my data set. In order to show that, it has to run all of those different functions. So that will trigger an action. If you're counting the rows in your data set, that's going to trigger an action because it has to print the number of rows. So when you're returning a value or printing a value, it's going to trigger all your transformations and then return a result with that action. We've already talked a little bit about this, but why do we want to do lazy evaluation? Why does that make sense? So if we have multiple joins and aggregations, if it can wait and get all of those things that you want to do together in a list, it actually on the back end generates multiple plans of how to execute all of your things in your list, and then uses a cost model to actually choose and predict the best one that will happen the quickest. So that's by rearranging the steps, by assigning different amounts to different parts of the cluster. And it does something called shuffles. Shuffles are really important. You need to know that they occur because when you're working with really big data, you can run into problems when you shuffle and you don't know it's shuffling. So if you, for instance, are doing a filter, as I said, in a filter, you can, each node of the cluster can act completely independently. If something is over 6, it's over 6 in every part of your cluster in the same way. If you're doing something like an order by or a sort statement, so you're sorting your data in ascending order, one node has to check with all the other nodes to see if there are any data above or below the data that's on their node. In order to do that, it has to move the data between the different nodes of your cluster in order to get all that information in a way that it can digest it. This is very expensive. So when you have large data sets, it takes a lot of memory and a lot of CPU to actually do that shuffle. There's ways to optimize those shuffles, and we can talk about that down the road, but you need to know that it's happening. There are any questions?
So just one quick question about node. Is a node really a separate VM, a virtual machine, or is it just a separate storage area in the database? What is the classification of a node?
So a node, for instance, it's a section of a virtual machine. So if you checked right now how many nodes were on my Mac computer, you'd find that there are 8. So I don't know a whole lot about the computer architecture on the background, but I have like 16 gigabytes of RAM and a 256 hard drive. So based on the actual structure of my computer, it has 8 nodes. And I know this because I parallelize things locally. So one computer can have multiple nodes on it, if that makes sense.
Yeah, no, because it's so when we created the cluster in on the Azure server or in the storage account, the blob storage account, did it create multiple nodes that I just didn't see or know about?
So I'm going to show that in really soon. And you were actually creating it in Databricks itself, not on storage. So to keep that in mind as well. I think I have one more slide, and then I'm actually going to show what creating a cluster looks like.
Okay, cool.
Actually, so yep, this is my only other slide. I get this question a lot. How do I learn this on my own? So I've read massive chunks of both of these books while working to study for my Databricks certifications. The questions that Databricks actually partners with these book publishers, the book publisher O'Reilly, to make this to make these books. So things on the exam are going to show up from these books. I find that it's really easy. The best way to learn is to learn by doing. So choosing some type of project and then coming back and having a goal. Then going through a book, or if you do better with like watching videos or something like that, you could go that direction as well. And like this has coding syntax in it. It explains things in detail. It goes through all the architectural things I just talked about, but in way more detail. And it'll help you through that. And then you can use it to reach whatever goal that you have. In general, this class, I'm going to try to cover things where you where that will help you prepare for the Databricks certifications, which I link to here. I've passed already the associate developer. I'm going to be taking the machine learning practitioner pretty soon. But this, you can think of it as the AZ 900 or the intro or 101 of Databricks certification. So it talks about the basics, filters, joins, the basic things that you would do in Databricks. Seeing a question. Hi, Kelsey. What if we assign the work to 4 nodes, but one of the workers failed? Will we get nothing, or can we still get results from the other nodes? So in general, cloud architecture does something that's called fault tolerance. So when something it breaks down, it usually has a snapshot somewhere else where it can actually move that to the other nodes and actually help you process it. So it's being backed up to an extent on where if one of them does fail, you don't lose the data. I don't know the details of how that looks on the back end. I haven't quite delved into that architecture, but the answer to that is yes. It's fault tolerant. It will keep going. It will not break. And you won't lose data. Right. All right. And now we can go in to actually see kind of what's going on. And then I can show you the difference between tasks and the transformations versus the actions. So right here is my Spark cluster that I created. I'm going to go through the process of creating another one just so I can explain. I'm not actually going to create it. So you would assign whatever name you want here to your cluster. And then you have a whole bunch of options here. And this will help you understand the difference between workers and drivers and things like that. So you would put a name here, just put test for now. This here, you can think of it as the version of Databricks that you're running, or the version of the software. So if you do push the drop down menu here, you're going to see many options of different versions of Spark. They are going to automatically put you on the latest stable version. If you're using machine learning, I would recommend using one of the ML options. Only use the GPU if you're doing deep learning or some reason where you need a GPU. GPUs are expensive. So you don't want to use this unless you're doing deep learning or something that calls for GPUs. If you're doing machine learning where you just need normal CPU, most things other than deep learning, you can choose this. The difference between an ML and a normal one is this has machine learning packages preloaded on it. Whereas this one is just kind of the bare bones cluster that you get. We're going to use this one just because it's going to work fine for our use case. Now, I'm going to come back to enabling auto scaling. The second one here, terminate after 120 minutes of inactivity. This is important. I recommend keeping this on, and if you're really cost conscious, actually putting that down to a much smaller number. So every hour you get charged, say if I have this low one, it's probably around 8 cents for each virtual machine, and I'm going to change these numbers. So basically, if you don't run anything for 120 minutes in this case, it's going to shut down your cluster automatically. This keeps you from leaving it on by accident, which I've done so many times. It's really easy to do. And it would rack up a really large bill that way. So in case you forget to turn it off, this is here as an option to turn it off for you if you haven't run anything in 120 minutes or whatever you want to change that to. Now coming down to the worker and the driver. So the worker type, in our case, we're using small data. So I highly recommend piping this down to 1 and piping this down to 2 for your max workers. And this account may not have enough CPU. Yeah, that's I don't know why that's going on. It's probably not a problem. So we have here many choices of sizes of clusters to choose from. So for really big data projects, you would want to go up to maybe one of these. They also have memory optimized versions where you're using high memory. They also have storage optimized options, and then GPUs, which is like deep learning, things like that. For the smallest cluster you can use, and the cheapest one is actually here. So if you want to use the smallest, cheapest option, standard F4s is going to be the cheapest thing available. I'm going to use this one for now, but you can use whichever one. You can also make your driver and your worker nodes different sizes. So if you, how do you choose this number of workers? So I know that I'm working with something that has it's not very wide. It's got a couple thousand rows of data. You would want to use something that's very small for that.
What's not very wide?
So I think I probably have 20, 30 columns.
Okay.
By wide, I would say like 1,500 columns. And that's what I think of as very wide. So when you're doing feature selection for machine learning or something where you're winnowing down those features, that's going to be something really wide. So you honestly have to make a guess here. I will say that scaling out is better than making the nodes themselves bigger. In general, when your data grows, you want to scale out. And you may want something bigger than this. So if you're using really big data, you would want to go maybe with one of these options instead. But then tend to go towards using more worker nodes. And you can start the cluster, you can try your analysis. There are ways to monitor how much memory and CPU are being used and what percentage is left. And if you're running into slowness, you'll have to shut down your cluster, resize it, and then kind of start from scratch. So this, you get a good feel of this after you've used Spark enough of where you need this to be. For this particular use case, this is going to work just fine. We're going to have no problems. So this would be using 3 virtual machines, one for my driver, the communicator, and saying what these worker nodes should do, as well as the different worker nodes here. So we have 2 worker nodes. It's going to auto scale between 1 and 2 worker nodes based on how much we need when we're actually doing data processing. So it'll be default 1, but if it needs more, it'll increase it to 2. I'm not gonna create this because I already have a cluster. It takes a little bit of time for your cluster to heat up, so keep that in mind. Now I'm gonna go in. I had code in here for you. There are instructions on how to set up storage. You can use this piece of code to do it, but it's in those same instructions that are sitting in the resources. And you just have to plug in some values here to get it to work. And you have to upload your data to storage. So see those slides to show you how to do that.
Just one thing, I was having trouble because I had opened the workspace and uploaded the thing, but my cluster up on top was blank. So I kept trying to run the code and it wasn't running. And I was wondering, well, it's Shift Enter.
Well, you
then
have to
I realized,
uncomment it. Yeah, so you take off those.
But you can't run this until you pick a cluster.
Yes, you have to start your cluster first to do really anything.
That was missing in the instructions. So
yeah, and that's going to happen sometimes, like things that I think are second nature, and you just got to point those out, just like you just did. Sometimes I don't think through because I've been doing this for a long time, like those granular things, and they're good to tell me, and then I can make an adjustment for next time. So I appreciate the feedback, and it will help me teach you better.
That was the only place where I got really stuck, but at that last piece of instruction, because I kept hitting Shift Enter to run the code, and it wouldn't run for me because I didn't have a cluster picked out up on top.
Yep. You have to start that cluster to really load any data, because your storage is going to be associated with that too. Right. So you would uncomment this, and you would actually run this. To uncomment all at once, you click Control and then the /. So you have to make sure it's all highlighted, and then you can recomment it with Control and /. So keep that in mind as well, to comment on and off your data. So this here, I made this dynamic. So all you would have to do is set a folder name here once your data is actually in storage, and it should run as long as the folder name up here is the same as the folder name here. So I'm going to run that. It's going to say sending to cluster, and it's now attaching to my cluster. So it's attaching the notebook to my cluster and getting ready to run this code. And you'll see it as it runs through this. So that'll take just a moment.
Question. Where is the code for setting up the database that you have?
So that is all in the Databricks setup guide that I emailed you on Tuesday. So it's going to go through that step by step in here. I found when I did it in the class itself, people weren't getting much out of it because it's hard to do and kind of show people and have people follow along. So in here have arrows, I have color coding, I have both written in words and in screenshots with like color coded squares on them. So you should be good to go there, hopefully.
Okay, great. Thanks.
Yeah.
And you just ran command 5, right?
So yes, I did. And now you can see that it's has all 5 of my data sets loaded in. from the storage. So it attached the storage and read these in. You can see that I'm using spark.reads.csv, and it's pulling those in. The next important thing, other than like the file path here, is the infer schema. Infer schema means it's going through a number of my rows, and it's taking a guess at the data types that my columns are based on the first, I don't know how many rows it looks at, but a subset of your data. And based on what it's seeing in the first, I don't know, 200, whatever it is, rows, it's going to guess that data type. You can set that explicitly, and you should do that for very large data sets, but I'm going to save that for another class. Inferring the schema is what I do most of the time. So where it's going to mess up is, say you have a column with a bunch of strings and you have one number in it, or something like that. Or the opposite. You have a bunch of numbers with one string. That's when it's going to get tripped up, because it's making a guess with a subset of your rows.
So I'm sorry, I'm a little bit lost.
Mm-hmm.
So when you say read in data files, so that LinkedIn analysis database had something
Mm-hmm.
called industry_growth. Was that a column name?
So these are the objects that you're assigning the data to. So
Okay, so I created those. Those are whatever I want in my database.
Yeah, and this class does have a bit of a prerequisite on it. So if that kind of stuff, I'm not going to be going over as much. I recommended to take this if you knew Python to a basic degree. So that's something that if you want to review Python, you would find, because I don't really have time to go over data types and objects and all the basics of programming itself. I'm going to go over the PySpark syntax. So hopefully that's okay. If not, I would try to learn a little bit of Python on the side. This is definitely like a basic programming thing that you would learn.
Well, I knew that. Okay,
Python.
so that's just a Python variable string. So that's what that is.
It's assigning this to an object. So when you tell it what that object is, the name of your data for these individual ones. So now this is a data frame, this is a data frame, this is a data frame. Okay. So that works just like it would in Python.
Okay.
So, and the equals is always in the assignment. So we're assigning this to this. So equals is something different. So we'll cover that in a bit. So now we talked about transformations versus actions. We talked a little bit about this. This is an example of an action. So if I run this, it's going to display the first 1,000 rows of my data here, and it's printing something. So in order to print it, it has to run transformations in order to get this data. When it runs an action, you always see at least one Spark job listed here. We already talked about that. And if you look at this, the jobs are going to have stages. And within the stages, there are sometimes, in this case, there's one task, but in some cases, there's multiple tasks. And tasks are what are happening on each individual executor. So that will make a little bit more sense. And I'm going to show what a transformation looks like in a bit. So what this does is it allows you to see at a bird's eye view what the data looks like. This data is from the World Bank. It is based on LinkedIn data from different countries. And it talks about talent immigration in and out of those different countries and different industries. So in this case, there is migration in the United Arab Emirates is the country it's talking about. That is considered a high income country in this data set. It's in the Middle East, which you probably already knew. In this case, we're talking about manufacturing, specifically defense and space. And it is listing what the migration looks like. So there are individuals migrating. From the United Arab Emirates to other areas. So that net per 10,000 K in 2015. So 425 per each 10,000 people are migrating out of the United Arab Emirates to somewhere else. Other data sets talk about one place to another. This is just overall outside of the United Arab Emirates. So display shows the top 1,000 rows. This I'm doing is also an action. So this action here is doing something called a grouped aggregation. So that grouped aggregation is taking our object. You can see that this is up here, the migration industry data frame that we loaded. It's using a group by statement. I'm going to throughout this compare and contrast PySpark to Python. So you can see what the differences are, and this is one of them. So in Python, this would all be lowercase. There would be no capital B. In every function in Databricks, the first word is lowercase, and the first letter of each word after that is uppercase, with the rest being lowercase. So you can see that in order by, group by, and average is one word, so it's all lowercase. And in general, you string different functions together to then do multiple tasks. I got the question this morning, why is it efficient to string things together? You would actually have to assign each individual function to a new data frame name, and then assign that data frame to the average, and then put that a new data frame to the order by, which is hard to read, and it's a lot more coding than you need. The back end, it's going to look the same, I will say that. And there are more complex code that doing that would be next to impossible. And we'll see something like that in a minute. So what this is doing, it's grouping by the ISIC section name, which has to do with like the industry. It's a bigger group of the industries. We are stringing on by putting a dot here, the actual average. In this case, we're looking at the net per 10,000 K migration in 2018. It's finding the average of this grouped by this. And then I also tacked on an order by. So that's a sort. So this is going to sort, and this is the automatically created column name. I'll show you how to change that because this is ugly. You never want this for an actual data frame you're going to use. But it will order by this created variable's actual value. So you can see that down here. It's ordering by the migration for different areas. So we got negative migration here. So if people are migrating, it would be to it. And then, whoop, sorry. You have to be clicked on this to do that. And then down here, you're going to see at the bottom, it goes up. And then the migration here is higher. And you're seeing the ones that with missing values actually have higher migration values, which is something to keep in mind when you're actually using your data. I messed up this code earlier today. So, but what is being shown here, and the reason I messed it up is I can't copy and paste here as I could before. So migration industry, what is the problem here? And I'm gonna just avoid this issue by running this first. You might have a problem with that. If you hit an error, run this one first, and I can fix it for the next class. So this is, I'm not sure, and this is what I was running to this morning. So even though I'm actually uploading this average, it's not finding it. So I'm not totally sure what's happening there. But you're basically, when you add the descending here, you have to load the package in now, and it's not able to find that. So I'll have to look this up, figure out what's going on here and why it worked before when I tested my code and it's not working now. But the idea here was to show you that in order to sort and order in a descending order inside the order by statement, and this is the correct syntax, we actually have to now use something called a column. and tell them that this value is a column, and with that column, we want to use a descending order. And this is just something you have to look up until you learn it. When and when not to use this column versus others. It doesn't seem to have a huge pattern to it that I've noticed. So this is the only thing that's different, and that's to add the descending order. What we're doing here is actually loading in packages. So I was kind of surprised that it didn't work when I loaded in average here. So I'm basically building on this every step of the way. And what this is showing, when you do grouped aggregations, you usually want to know about more than one variable or about more than one metric. And this shows you how to do that, because in reality, that's probably what you're going to want. So we already covered the average, and there's a couple things that are different about this one. So we are doing using multiple columns and multiple summary statistics. All of that is done within the ag function after your group by. So you'll see here, if I hover and put my cursor after this, you can see that this entire area is within this aggregate function. So if you get mixed up with your parentheses, you can actually see which ones are related to the rest. So the first one we're using is a count distinct. So counting the distinct number of country values in this case. And then the alias is renaming that actual column to country count. So it's not that ugly thing with the parentheses. And then this allows you to, it doesn't do anything. It's just telling you it's writing the command on multiple lines, just so it knows to keep looking. And not to just run everything on one line. That's for readability's sake. It's not functionally necessary. You could do it all on one line if you wanted to. And then the next things we're doing for the net per 10,000 2018, we're finding the average, the min, and the max. And then we're again setting those alias values to change the column names. And finally, tacked on after the aggregate, so it's outside of the aggregate function, is again that order by that we just saw. And all of that is sitting within a display function because we're printing this. And when you run that, we see here all four of the columns we created and what is in them, and they're in descending order by the mean value. Or ascending order, sorry. One other really neat thing, and I actually forgot to show it up here, but say you want to graph something and you want to see really quick what it looks like. All you have to do is click that. This is a Databricks thing. This does not in other Spark platforms. Now we can see this graph automatically, and you can actually change the plot options and download it if you want. Pretty cool. And then you can just click back and it'll take it back to the chart here. Now, I should have a moment more. I do want to show this. So I'm going to comment this out real quick and run this. This shows a transformation. We talked about the actions versus the transformations. Up here, I printed something. So it had to return and print a value. Therefore, it had to run all of my transformations. So all of these functions here. So you're seeing a Spark job here because it's actually running multiple jobs. So it's running the group by, the aggregate, and the order by. And then each of these have different stages. Down here, you're not seeing a job. That's because I never called any of these values. So this is the exact same code above, except it's assigned to a summary data frame. Since we're not printing anything anymore, it's putting these transformations in a line, and it's waiting for us to actually print or count or do something like that with this summary variable. So you're not seeing any jobs down here. This is important because if you see an error, it's not always going to be associated with the cell that you're running it on. So say we have all of these things occurring one after the other in a line. You could see the errors show up here, or you could see the errors show up when you actually call and use the summary in an action. It's something to keep in mind, and you have to read the error messages to figure that out, which one's which. And finally, then we'll stop for the day. Right here, I'm going to actually print the columns so you can see what those column names look like to make sure that these changed. So we have 2 minutes left. Are there any questions that you guys have? And then we'll move on and we'll just keep going the next time. All right.
I just got one question. So I've been trying to follow along. In the command 5, for some reason I'm getting an analysis exception error. It says it can't find the path, even though I got a true above.
So you probably didn't run this cell because the path is set here, not up here. So you have to run this here.
Okay, I thought I did, but okay.
Yep. So that's probably what's going on.
Let me try.
And that path is set here. Yeah. Are there any other questions? Go for it.
So I have not installed Azure and Databricks till now. So is it available free or does it cost something?
Yeah, so I've mentioned that and it does cost something. So, and I don't know if you came on late, but it costs like, you can actually look up the prices. So the virtual machines that you choose, if you Google Azure virtual machine prices, it'll come up. So it's going to cost probably, what I'm doing here is probably going to cost me 30 cents when I get a bill. There is a free trial, but it'll only last for 14 days. Then you get a $200 credit for 1 month time. If you are not comfortable with that cost, you can either use Databricks Community Edition, which is free, but it does not have the full functionality that you may need, or you can actually set up a local Spark cluster on your computer. I've never done that, so I can't help you through it, but there's a lot of documentation on how to do that online. So if you want to follow along as I do it, Databricks may be the best option, but if there are cost reasons why you can't, Databricks Community Edition and the local Spark cluster are your best options.
Okay, sounds good. I'll go through it. And so it is costing 30 cents per hour or
so Azure. So if you Google this, Azure Virtual Machines, the pricing will come up. I was making a guesstimate. So you'll see that those virtual machines that I had in there, DS, if I can find, you'll see that these are going to be listed. They'll be listed somewhere on this page. So you'll just have to find the values, but you can see here per hour, and it gives this particular one is 2 cents an hour, basically.
Okay.
And then you can look back at your cluster size here. You can see what the name of that cluster is. And in this case, I have 3 VMs of this size. So if I look at, what is it? DS3. Okay. So since I'm on a Mac, it annoyingly won't let me use like the shortcuts. So DS3. Here you go. DS3v2 is what I'm using this one. Yes. So this one is costing me 20 for each one. It's costing me actually 23 cents an hour. So multiply that by 3 and that's what I'm paying. The I told you earlier what the cheapest one was. It was F something. I would have to go in. The cheapest one here is this one, standard F4's S. So if you look that one up, So that's not the same one. This one here. So it's it's on the cheaper end here. So it's a little bit cheaper than the one we just saw. So that one is about 20 cents an hour.
Okay, thank you.
And always keep in mind the numbers here. So you would never want to do this because you would be paying for 9. You don't need 9. So, and if you work for a company that uses Azure, there may be a possibility, depending on what level of company they are, that there will be a $50 credit that comes free to your company. Something to look at. AWS, as far as I know, does not offer that. I have no idea about Google Cloud, but we, as Avanade employees, get $50 every month to play around with. So, all right. Are there any other questions before we sign off? All right. Thanks, everybody.
Thank
Hope
you.
you had a good time and you got something from it. Bye.